Hey guys, welcome to Build Onchain. Today we've got Lucian Stroie from RISC Zero. Lucian, why don't you tell us a little bit about RISC Zero and Boundless and how you got here?
Hey, my name is Lucian Stroie. I head solutions engineering at RISC Zero, and we recently launched the Boundless network. It's the universal ZK protocol, and it's effectively the blockchain native way to request and fulfill zero knowledge proofs on any blockchain. So, yeah, it's a great pleasure to be here, and thanks for having me.
Awesome. Can you tell us a little bit about what RISC Zero is doing today? A little bit more about Boundless, just kind of like rough intro of it. Yeah.
Yeah, so RISC Zero invented the ZK VM, or at least implemented the first RISC-V ZK VM that the industry has coalesced around, and major blockchain ecosystems have shifted their entire roadmap to focus entirely on. And first, let me take a step back. Zero knowledge proofs, it's a cryptographic primitive. I think it's the most important cryptographic primitive since public key pairings, but it's effectively a way to share information in a way in which you don't reveal anything about the underlying information that you're sharing. So in the blockchain setting, you can essentially prove the accurate state transition of a blockchain without actually providing the blockchain state that went into that state transition. Therefore, it's become basically the only way to scale blockchains without increasing the size of the nodes, the network requirements, and it's basically a new cryptographic tool that is essentially the next frontier of blockchain scaling.
Got it. So you don't have to, basically you only have to provide the proof rather than all the information that's being proven?
Correct. Yeah.
Okay.
And the proof is extremely compressed.
Mm-hmm.
And you basically can ask this proof like, hey, is my transaction included in this? And you have the cryptographic guarantees saying like, yes, your transaction was in the latest block hash. The latest block hash was signed by like all of the validators of Ethereum, for example. And I'm giving this example having just launched Boundless's mainnet beta today. And in doing so, we actually are the first people to prove Ethereum full consensus in ZK, which means we basically took all of the signatures that participate in a single epoch of Ethereum, which happens every 6 minutes. And we compressed all of those signatures and essentially re-verified the valid block hash of an epoch in ZK. So I'm going to jump to your next question. It's like, what is this used for?
Yeah, please.
Right. Like it's super technical. It feels like a bit esoteric, but it's a primitive. And it's a primitive that essentially takes the entire Ethereum consensus client and it compresses its execution in such a way that it makes it portable. So I could prove the entire Ethereum consensus on Solana, on Ripple, on Stellar, right? And it makes any state transition on Ethereum portable.
Okay. Super, super cool. I'm told you have a demo for us. Is that the case?
Yeah. So Boundless is basically a two-sided marketplace. You have the ability to generate proofs and submit them to be fulfilled by anyone. And mainnet beta actually allows us to fill those proofs. We're the only permissionless, open, decentralized prover marketplace. And I'm going to show you how to rent a cluster of GPUs and how to start mining zero knowledge proofs.
Awesome.
So, yeah, let's do it. First, I kind of wanted to walk you through like exactly what our end goal is, and like I wanted to basically show you how you participate in the network. And there's orders Orders are basically people who are requesting a proof. This is the requester address, and this is the prover that submits an order. But I kind of just wanted to drill in and show you. Currently, it's deployed on base mainnet. So essentially what's happening is you, as a requester, submit a proof with a starting price and a ramp up period to a maximum price. And provers are essentially able to lock in a proof request and just start working on it and start like doing the mining to actually resolve it. And the first status is locked when someone accepts the order, and that basically prevents duplication of work. The second step is fulfillment. And the fulfillment of proofs is basically where after someone locks up the proof, they do the work in order to compress the computation, and then they submit the proof to be verified on chain. And the idea is that we actually can calculate how many cycles have been generated, and I'll go to one where it's already calculated in the future. So we can basically attribute 7.3 million cycles specifically to this prover. And the idea is basically we have a network that has the ability through another thing that we've invented called proof of verifiable work, which allows us to aggregate all of the cycles proven by a specific prover over a period of time. And for us, it's going to be a reward epoch of 1 week. And you can basically aggregate all of the proofs that were computed. And then this gives you like a proportionate weight of how many proofs were done by this specific prover over that period of time. So we have this ability to essentially reward this prover proportionate to the amount of work that they did in the network overall. So that's kind of like the high level summary of how the network works. What we're doing is essentially becoming a prover. And we're going to rent a cluster of GPUs, and we'll talk about like which ones, like why am I picking that? And we'll kind of walk through it while we actually get one set up. So I'll walk you through the step of like picking up some GPUs off of a distributed GPU marketplace and getting set up so that you're filling proofs and so that you're essentially mining ZKC, right? So you're essentially mining ZK proofs.
Awesome. Let's do it.
Cool. So I'm going to start with a GPU rental provider. And right now I'm using vast.ai. I've already set it up. I have a few dollars worth of credits to enable this demo, and I already have an instance, but I'm going to pick the Ubuntu 2204 image, right? I'm going to select it. Then I'm going to find a GPU. I make sure that I have over 200 gigabytes of disk space. Wow, it seems like they actually are running low on GPUs, but whatever. I'm probably just going to spin this one up, and then I'll switch to the existing instance in a bit. So I rented the instance. I already had an SSH key set up here, so I can be able to log into it. But yeah, it's fairly straightforward with regards to what I'm doing. Right now, I want a 4090 specifically. Our ZKVM is optimized for high-end consumer-grade graphics cards. 5090 from what we've measured is the most performant. Given how they're unobtainably expensive, though, like don't feel like you're at a disadvantage if you're operating on 4090s. I also have, just for the sake of demo sake, my own 2080 Ti mining here on my gaming PC. So when I open the terminal, you'll be able to see that as well. There are performance disadvantages. So in the selection of a 4090, I think the important thing to note is ZK is not machine learning, except VRAM is always king, right? Once you have enough VRAM, and we'll go into more detail with regards to what that means, the next thing is compute cores. So newer cards have a higher number of CUDA cores, and the end result is that they're more performant. 4090 is still a great card, and it serves exactly the needs that we need for this demo. So this machine is still starting. So the other things to look for is the fact that we have a minimum of 8 physical cores. So this usually means that there are 16 V cores. That's the minimum hardware specifications. And if you go to our website, which will probably be linked, called beboundless.xyz, you'll see the full requirements for GPU proving. But right now, I'm interested in having 4090, over 200 gigabytes of storage, and like more than 8 CPU cores, right? The idea is actually to get as many GPUs in the same cluster as possible, but I'm just kind of being cheap for the demo's sake. So the next thing that I'm going to do is I'm going to copy this SSH password, and I'm going to switch to a terminal, log in first, and then I will connect and switch the screen share over there. So while I'm doing this, do you have any questions for me so far?
Yeah, I mean, maybe this is kind of a simplistic question, but I like to ask stupid questions, you know.
Please.
So yeah. When you say like, you know, that you're running a prover, I guess, you know, what does that entail? As a if I wanted to run a prover, like what would I have to do beyond that, and like what does it mean to run a prover, I guess?
Yeah, so our proving software, as you will soon see, is actually split into two.
Mm-hmm.
It's split into two services. There is the actual like GPU orchestration layer, and we call that Bento. And there's the broker. The broker basically does all the on-chain order matching, like order fulfillment, all the optimizations with regards to like what is the price that you are accepting proofs at, and like the actual logic for making sure that the GPU cluster is orchestrated profitably, right? Mm-hmm. So you have the compute, and then you have like the order matching and order generation standpoint. It's designed this way because we are dealing with like massive data center, publicly traded companies, largest Bitcoin miners in the world, like our provers today. And they have the ability to customize their order matching to match the scale of the and distribution of their own data centers. We're just running it on the same machine. Mm-hmm. So, yeah, the interesting thing is that like, hey, how am I going to be competitive like when I'm dealing with publicly traded companies with like hundreds of thousands of GPUs? And the truth is that ZK is still pretty early. You have access to the same software. This product is brand new. You're early. Like, we are the first fully decentralized ZK prover marketplace. And as a result, like, we're not at the point where you have to build custom ASICs yet. That's why we're running this on commercial over-the-counter GPUs. So, okay. Yeah.
Got it. So then, like, yeah, the comparative advantage that you'd get here is like not impossible to get, just because of how early we are.
Advantage is subjective, right? So that's actually something that's a good call out, because the advantage is basically just like in proof of work. If there is too much proving supply, then you may be unprofitable, right? If there isn't, right, then you have the opportunity to essentially prove. So there's absolutely no guarantee of return. However, given that the incentivized mainnet beta of our network has just launched, we're essentially bootstrapping both the supply side and the demand side together, and we're essentially showing you how you could get involved in the supply side of ZK compute. So there's going to be an equilibrium that's established, and there is a lot of room for improvement and a lot of areas for optimization left. So you could overclock your GPUs. You could for example, move to an on-prem data center. You could own the GPUs as opposed to rent them. There's different ways where you could get an advantage, but end of the day, just like proof of work, it really comes down to a very large macro economic stabilization question of supply versus demand. And supply is just getting bootstrapped. We actually are recording this on the day of our mainnet beta launch. So
congratulations, by the way. Yeah, huge stuff.
Yeah, the timing lined up. So yeah.
And then just one more thing. So basically, if I'm understanding this correctly, Boundless is the economy in this case, right? Where right now we're demoing, being a participant in it, but Boundless is the economy itself, the ability to, come I guess to participate in this and to get potentially to profit off of providing proving capability.
Yes.
Super cool.
So now I'm going to be pulling up the virtual machine that I just rented on vast.ai. And it's basically a blank virtual machine. However, if I just check what NVIDIA GPU they have on there, it's the 4090 that I just rented. So the setup is actually pretty simple. First, I'm going to pull the Boundless software, check out the latest release, which at time of recording is release 12. And I'm going to just run the setup script. Now, the setup script is pretty involved. There's a pretty tight coupling with the ZK virtual machines and very specific versions of CUDA. So the end result is that the compilation time takes quite a bit. And in knowing this, I just wanted to highlight just how simple it is to get started. But also, I already have a machine set up here. So the Docker images are configured, but they're not actually set up. And while this is running and this is getting set up, I'm just going to hop into this machine that has all of the required instances set up. On this one, I do want to highlight one key difference. This one is the one with two 4090s, for example. So the packages, as I mentioned before, are basically broken into the Bento cluster. And you can think of the Bento cluster as the thing that munches ZK proofs, right? It's the thing that actually heats up the GPUs and keeps them well fed. So what I'm going to do is I'm essentially going to use the just commands to get started. Prior to that, I actually did want to mention the fact that the only configuration that you need are chain-related configuration. So I'm going to bring that up front now. You're going to want a private key, an Ethereum-based private key with gas on it. The networks that we currently support are ETH Sepolia and Base Sepolia. We're also on Base Mainnet. So you can actually specify a RPC to either of those three networks. And then I recommend using the free tier of Alchemy. You need WebSockets. It's a really good, reliable one. And you don't actually exceed the free tier limits. So that's a good place to start. So to go over that again, you need a private key with gas money and USDC, actually. Like an RPC, a private RPC, with a token, because you need WebSockets connections and you need fast, reliable responses in order to actually participate in the market. So I just noticed that the screen has not shifted to my other terminal window. Let me see if I reshare. That will work. Hopefully now. Yep. And now we can see the screen with 249 days.
Yeah. Okay.
Yeah, cool. So the next steps are getting the Bento cluster going. And first, normally I would run this command. Normally I would run this command in order to actually set up the actual Bento client at the latest. However, I've already done this, so rather than overwriting some of my potential configs, I'm actually just going to start the cluster. I'll actually go back in and explain some of the configs that I had to change so that there's no surprises. But let's get it running first. You want to run the command just bento, and of course you actually have to be into the right repo, and then you have to run just bento. So essentially what has been created is a Bento cluster that has the ability to prove ZKPs. Within this package, we've actually provided a pretty simple way to test whether the actual ZKPs are correctly being proven. And this allows you to essentially isolate the actual proving from the rest of the on-chain services, and allows you to kind of debug them separately. So the idea is basically to run some test proofs. This is essentially running a spinner that in a loop that runs 32 times. So it initializes the job, and you'll see essentially how long it takes to calculate these 32 recursive loops within the ZKVM. It takes a little bit, but it's a good kind of segue with regards to what exactly are we doing here, and what is the impact of the number of GPUs, and how does it relate to ZKPs? So if we actually switch terminal windows, which it doesn't do easily. So I'll just hold off. To demonstrate this example, I'm actually going to set up on my local machine that has a 2080 Ti. I'm actually going to spin up a Bento cluster here. And I'm going to run the same loop. And you see that the job was done here.
Mm-hmm.
Right. So what I'm going to do is I'm going to start it on the on here first. And then I'm going to start it on the 2080 Ti. And you can basically tell the difference of like the graphics cards, the relative performance, the benefits of having two graphics cards as opposed to one. So there's a background process running on my local gaming computer as well. And the thing that I'm trying to demonstrate is more GPUs is more better, right? Like
Yeah.
it's pretty straightforward, right? This is actually like the killer feature of ZKVMs and like the amount of engineering effort that we put is basically to allow for the parallelization of computing zero knowledge proofs so that you can just throw more GPUs at a problem to get faster responses, right?
Yeah.
Yeah, and like when we actually get to the maximum, like the limits of performance, we're getting to the point where we can prove Ethereum in real time, which
Wow.
basically means like we could run the Ethereum virtual machine as fast as we can prove it in a very scaled up cluster. So that last asterisk is essentially like what we're doing now, right? You see this finished here. I'll let you know when the 2080 Ti finishes as well. So yeah, the idea is basically like we have the ability to add more and more GPUs and like prove faster and faster. And this basically means that rather than like waiting for a longer amount of time before ZKP is resolved, we can essentially have more scaled up clusters of GPUs that crunch through proofs faster.
Mm-hmm.
Yeah.
Awesome.
So the end result is like people who build specialized infrastructure for ZKPs have the ability to essentially have a higher premium in the marketplace because they're able to prove ZKPs faster.
Right.
Yeah. And there's like an actual objective metric that we use for this. Since we can count the number of cycles that are proven, and there's the time component as well. We can essentially measure the performance of a ZKVM in megahertz.
Okay.
Yeah. And as a result, we have the ability of like measuring how fast we can have a ZK-based program. The other thing is that these programs are also vastly parallelizable as well. You can take one zero knowledge proof and prove it inside of another. So the parallelization that happened to these GPUs within a single cluster can also happen completely independently at the program level.
Okay.
Yeah. So in Ethereum specifically, like you have this roadmap and you have L2s, and they're all essentially going to be running on ZKVMs. And they're just churning out cycles and they're churning out proofs. And then you essentially post the results of the proofs on chain, on Ethereum mainnet, on L1, and then you recursively prove them as well.
Amazing. It's like not too much of like a, I mean, very little, I would imagine, like performance like delta between like running it and not running it.
Yeah, exactly. And the verification of it is nearly linear.
Mm-hmm.
So you can add as many L2s as you want. The verification cost of them, like, yes, it is Like there is a cost overhead to verifying a single zero knowledge proof inside of another zero knowledge proof, but that's completely a manageable and sustainable cost, especially when only a single prover essentially gets to bear it, right?
Right.
So you basically offload this computation to a single cluster of GPUs, and you're able to do this at the L1, at the L2 phase, and you're able to aggregate them. And this is effectively the new Ethereum scaling roadmap as they've laid it out. We're basically already there. We have the ability to run both L1s because we were the first people to prove Ethereum Consensus in ZK. And we also have the ability to run like full proofs of the EVM in ZK as well. And we have a rollup stack based off of the OP Kona branch. Like we built a version called Kailua. It's a custom Finality gadget that essentially runs the OP Kona fraud-proof game inside of ZK. And by compressing it in ZK, we have the ability to reduce the withdrawal window to just 3 hours in fraud-proof.
All right, that's so cool.
And here's the kicker. If you prove every single block, you could run it in validity mode, and you essentially have the finality at the speed of proving. And you have the ability to start in fraud-proof mode, which you only need to pay for ZK proving in like the case of a dispute. You automatically reduce the finality window to 3 hours just from that. And then if it's economical for you, right? Because who knows where the price of proving in ZK will be after Boundless is fully launched. As you saw, everyone is accepting proofs at $0
Yeah.
right now. Right. So it's like that's day one, and it's like essentially we just need to keep increasing the requests on the proofs until basically like everyone is locked up and the price is time to actually scale. But yeah, effectively, we have this ability to just start proving every L2 and compressing them on L1 today.
Insane.
Yeah. Yeah. And like the crazy thing is that this is like also Ethereum's 5-year roadmap, right? But we wanted to basically demonstrate that like we can do it today, even without the consensus client changes that are proposed, even like with existing roll-up technology, like we can just run it.
Wow.
Yeah.
Super, super cool.
So to kind of get back to the next step of, we have a Bento cluster, but it's not connected on chain, right? Like it's just proving, it's just doing ZK compute. The next part is actually interacting with the on-chain orders, right? And the way that it works is like a requester submits an order, and then you have to run a broker service. It has an event listener. You pick up orders. You first execute them locally on your machine, and you're like, oh, okay, this is like 7 million cycles, and I have 10 minutes to do it. My prover can do it. So you place a bid as long as it exceeds your minimum price. And then you have a fixed amount of time in order to submit a valid proof while your GPU like is running it. So yeah, essentially what you're going to do is set up the CLI, which again on this machine is actually already set up. You're going to deposit stake, because if you don't fill that locked order in time, you will get slashed. For Boundless testnet, these are actually, it's USDC. So in our current phase, you're essentially risking USDC on this. And then finally, you're going to run the broker service. So I'm just going to write just broker. Okay, so now we're going to run the actual broker script, and it's just broker. And this basically handles the coordination layer to the blockchain.
Got it.
Yep. So now the broker's running, Bento's running behind it. So we can basically see that I have Bento running. There's essentially the broker is also going to be forwarding requests to my GPU clusters. And whenever I pull and lock a request from the marketplace, I'll actually be able to essentially start proving it. So effectively, that's it. That's all you need to do in order to get started filling proofs and mining ZK.
Amazing. And this is all like available, like nicely packaged up.
Yeah, it is. It is. So like it's all basically wrapped up into the GitHub repo on boundless.xyz. On GitHub, it's boundless_xyz. And yeah, I think we can kind of stop on like the CLI aspect of it, and we can probably flip. It depends. Where do you have questions? Do you want to know kind of like the flow of the order, the transactions? Yeah. What else would you kind of like to know?
Yeah. I guess like at a high level, I'm kind of I'm curious about like kind of like how like RISC Zero compares to like other like ZK offerings within the space, and then we can drill down from there.
Yeah. So RISC Zero built the first RISC-V ZK VM, and we did a lot of like heavy research with developing the actual like core technology. Then the contest became in prover marketplaces because the intermediation of basically the two-sided marketplaces between requesters and provers kind of became like the next competitive frontier. So our perspective is that a prover network needs to be fully permissionless, and the network topology matters a lot. You don't want to have centralizing components anywhere in your architecture because you risk becoming the reason that a blockchain has a liveness failure. So if you're running a centralized database and you're running a central limit order book for matching buyers and sellers of ZKPs, yeah, you could reduce latency. But if your database goes down, you bring down every blockchain that depends on you. Right. So we felt that it was really important to be able to request and enforce liveness on chain. So the way that Boundless is designed, it's a reverse Dutch auction on chain. And if you don't fill a proof that you locked in, you get slashed. So during this like mainnet beta phase, the amount you get slashed is rather inconsequential. Further on, it's going to become more and more substantial because you're essentially delaying the finality of a blockchain, and that has real world consequences and real costs associated with it. As you could imagine, like if you delay the finality of base 30 seconds in order to basically like reorg transactions or to have a sandwich attack become even more profitable, the amount of money that you could potentially claim just by acting maliciously within that design space is actually just massive. So yeah, we're the only network that designed this from the ground up to be censorship resistant, and to have the same liveness guarantee as the network that you settle on. Another really interesting kind of design consequence of this is the fact that Boundless is not just on base mainnet. Well, it is today, right? It's live on base mainnet,
Yeah.
but it's mainnet beta, right?
Mhm.
And it's because we're still upgrading the network. We're still ironing out kinks until fully launched. It's going to live on every chain. So the way that you actually request ZKPs is by simply submitting the inputs in a blockchain transaction, and then you get economic guarantees that if you paid enough for your ZKP to be filled, there's basically nothing that will stop it from actually getting generated and filled if it is valid.
Mhm.
So we've built the modules so that you could essentially make this completely autonomous. You can basically top up a smart contract that gets filled up with fees, for example, by a sequencer or some other logic on chain. And effectively, you have a censorship resistant application that is running on off-chain compute. So there's an aspect to economic security that is kind of extended through the boundless network design, and this is entirely unique.
Okay. And so this is like something that I find personally really interesting. Like when we talk about like what's it called? Like bonding for the purpose of slashing, the sort of secondary effect of that sometimes is you have like your set of entities that are able to make that bond kind of like you basically you end up creating kind of a size, like a natural economic size of the number of people that can be solvers or provers.
Mhm.
So I guess like what do you have like a vision of like what that size would be? Like, what does a prover look like? Is it going to be somebody like you or I? Is it going to be like a larger organization? I know you talked about like the GPU requirements, but yeah.
So we actually leave that up to the requester. That's a parameter.
Oh, super cool. Okay.
Yeah. And the token that you can pay for proofs, it could be in ETH, it could be in an ERC20, it could be in anything, right?
Mhm.
And the ZKC token for Boundless is solely for staking, slashing, and rewards for proof of verifiable work. Um, there's some really, really interesting consequences. We have stayed in like the purest form of simplicity because our actual goal is to drive down the cost of proving effectively to zero.
Mm.
And this is kind of like the way to think about RISC Zero and Boundless. RISC Zero made it possible to run any arbitrary code in ZK. In fact, we have a demo where we're running Doom with graphics in
All right.
ZK.
Classic. Love that.
So, yeah, like if it compiles, we can run it in ZK.
Dope.
And the converse part of that is like, okay, but like at what cost? And like we ran centralized proving infrastructure on AWS for the last year and a half, right? And like the AI race for GPU compute basically heavily subsidized the infrastructure investment
Mhm.
in like the exact type of hardware that accelerates our workloads.
That's awesome.
So
It's so like, yeah, very, very opportune timing there. It's really nice.
we found this amazing sweet spot where like 2 to 3 year old hardware that has just been beaten out for cost competitiveness for AI is
Mm.
just like Steph's kiss perfect,
You just farm
right? Like,
that. Yeah, it's perfect.
yeah, exactly. And all we have to do is just be marginally more expensive, marginally more profitable than AI workloads, right? And again, with our token economics, there's no guarantee of this, right? So it's
Yeah.
like it 100% speculative. That's actually just part of it, right? Like we have the simplest, most straightforward incentive structure where, like during this month of testnet, we are giving out 0.5% of our total supply,
Wow. All right.
right? And like having worked on the token economics, it's equally as simple because it needs to be. Like there is obviously risk associated with like renting GPUs and going into the prover marketplace and just doing the work. Conversely, just being that open and transparent, we hope, will drive the price of ZK proofs effectively to zero. And it just opens up this like new possibility of proving every single blockchain and making them interoperable within ZK.
Amazing. I have like one like sort of more like rather specific question, I guess. I'm curious. So we have the point of this economic security and like about the slashing is to prevent malicious behavior, of course. I'm curious, like what happens. Like let's say I'm a theoretical like terrible actor, right? And I am happy to pay this slashing cost because I am. What does that look like from a perspective of proving that request? Like, does it have to? I guess will somebody else pick it up? I get slashed. Does somebody else pick it up?
Yeah, you do. It's actually automatic.
Super cool. Okay.
It's automatic, and your stake actually becomes the reward that is put up in a new race.
Oh, lovely.
So,
Okay.
yeah. So once you get slashed, basically everyone on the network is like free money. Okay.
Yeah.
And it incentivizes people to essentially race to be the first to submit it.
Mm,
So whoever wins basically gets to keep your stake.
okay. And it's like an offset of that delay. There's no further delay at all. Okay. Awesome.
Yeah.
Super cool.
And like the proofs are interchangeable. However, we also have the ability to tell which prover did it.
Mm-hmm.
So like that has some really interesting consequences when like at the end of the week, we have the ability to tally everyone's relative contributions proportionally. So yeah, that's kind of the game that we've designed. And those are the incentives that we've designed. And we've tried quite hard to make the economic incentives simple with like the explicit intention of making proving as cheap as possible so that we could open as many use cases as possible.
Got it. I like it. So we're running a little bit long. I just want to ask a couple last questions. What does the like timeline look like for Boundless? For the full rollout. Can we talk about that a little bit?
Yeah. So today was mainnet beta, and we launched this campaign called the Signal. This is basically a demonstration that we're going to prove every single blockchain, starting with Ethereum. So this is the site. You can get involved. If you're not a prover, you can actually get involved and actually interact with the ZKPs. And here you can follow along with essentially like the steps that we're going to. We're starting with Ethereum, but we plan on essentially you can take the signal from Ethereum and you can then bring it to Solana today. And you can essentially prove that a specific transaction happened on Ethereum on Solana permissionlessly already today.
Amazing.
So the next step is essentially making it a two-way bridge. And that is going to be like a much longer journey. So this is mainnet beta. We're going to launch mainnet following this. And essentially we're kicking off the journey of proving every single chain in ZK, making them all interoperable with ZK Finality, and essentially like building this kind of new stack of how to design and implement entire blockchains using this new technological primitive.
Super cool.
Yeah. And you have basically the next month to participate in this Signal campaign. So you can participate by boosting or, as we just demonstrated, proving. So yeah, get started. And like the incentives are live and they're real. So you could earn USDC if you solve someone who was slashed, and you could earn ETH for proving that you lock in the marketplace.
Sweet.
Yeah.
Cool. Okay, I think that is all the time that we have. Thank you, Lucian. This was really, really cool, really informative. We're going to have the links to these things that were mentioned in the description of the video. But yeah, thanks for being a part of it, and thanks for sharing.
My pleasure. Thanks for having me on.